Hello again. Welcome to Tuesday and the end of our chapter on functions. So again, we're going to be taking a test in a few days, probably on Friday. Looks like the best day to get this thing started, which means we'll do some review on Wednesday and Thursday and give you a chance to kind of get caught up and ask any questions and prepare yourself. All right, so I'm not going to go through every one of these things line by line. I put a copy of this page. It's a little more legible. I know it gets a little blurry on here sometimes. I have a copy of this page posted on today's site, LMS page, so you can go ahead and open that up. You can print it out, you can save it, or just come back to it and open it. I think this will be very helpful for the test that's coming up at the end of the week, because this covers a large portion of the things that we've done, especially over the last few weeks. All right, so I'm not going to sit here and read through all these things. You can look them up yourself, but I am going to go through every one of these steps as I go through a sample problem. All right, so this is what your work will look like today. You'll have 3 of these. And again, with a couple of minutes of practice, they go a little faster. All right, so one thing that I could have you do on the left-hand side is I could rewrite that a couple of different ways if you don't like the way that equation looks. Could have also rewritten that as y equals 5 over x minus 2 times x minus 2, if that helps you see it a little bit better. Could have also written that as 5 over, and then go ahead and done FOIL. That'd be x squared minus 4x plus 4. So not necessary for that. You wouldn't have to do either of those, but if it helps you see things to write it out in a little bit different way, then that's fine. You could go ahead and do that. All right, so let's go ahead and find out what we are wanting to do. And again, I don't need those. So what we are wanting to do is to find some things on here. Sorry for the line. And again, if there's anything in here that you didn't know, you can go back and read. I'm going to go read some of them to you anyway. All right, so anyway, first off, let's find the x-intercept. So to find the x-intercept, what we want to do is set the numerator equal to 0 and solve. That's how we find x-intercepts. X-intercepts are the place where the answer is 0. So essentially what we're doing is we're setting the y part equal to 0. And for something a fraction to equal 0, it's the numerator that counts. 0 over anything equals 0. But if the numerator is not 0, you'll never get 0. So we don't have to worry about the denominator. We just worry about the numerators. Now let's go ahead and solve. Oh, wait a minute. There's nothing to solve. It says 0 equals 5, which isn't even true. Which means that there aren't any. None. There aren't any x-intercepts. That's possible. Absolutely possible. It's probably a good sign that there's going to be a horizontal asymptote on the x-axis, meaning the graph will get closer and closer to it, but never actually touch it. All right, so next, let's find vertical asymptotes. So to find a vertical asymptote, and there can be more than one of these, by the way, we want to factor both sides and then see if anything cancels out. Well, I did that earlier. I wrote the denominator in factored form, where it would be x minus 2 and then x minus 2, and the numerator is just 5. So there's nothing that cancels out. So what I now want to do is I want to set the denominator equal to 0 and solve. So that means I want to set both parentheses equal to 0, but those parentheses are the same. So I'm going to get the same answer no matter which one I do. I'll just be adding 2 on both sides, and x equals 2. So I am going to get a vertical asymptote at x equals 2. And you're going to be drawing that in, so let's go ahead and just do that now. Actually, let me make that a little bit thicker so it's easier to see. Whoa, that's super thick, but whatever. You can see the line there, my vertical asymptote going through x equals to 2. Let's look at the next line. Next one is horizontal or slant asymptotes. Both on the same line because we can't have them at the same time together. We can only have one. So if you remember, the rules were if n is less than m, we get the y equals 0. That'd be the x-axis. If we get the n equals m, we get the y equals a over b. And then if we get n greater than m, there's no horizontal. That's where maybe we get the slant asymptotes. Not always, but maybe. Only if n is greater than m by exactly 1. So sometimes we don't get any asymptotes at all for horizontal or slant. So let's look at this one up here. My n is the degree of the numerator. It's basically the x to the highest power. Well, there's no x's, so the degree is 0. My m, the highest power on x, would be a 2. That's going to be an x squared. Remember, if I actually multiplied out FOIL, I showed you those other formats. that denominator would have been x squared minus 4x plus 4, and you can see that the degree would be 2. All right, so that means that we have this situation. N is less than m, so we get a horizontal asymptote at y equals to 0. I'm going to go ahead and circle horizontal so that I know that it was horizontal. And since I have a horizontal one, I can't have a slant one. They don't go together at the same time, so I don't have to worry about that one. So I'm ready to move on to the next part. All right, so my next part was going to be, are there any holes? Well, if you remember, when we factored this, so here it is in that factored form, if there was anything that canceled out from numerator to denominator, that's where we would have had holes. So we don't have any of those. Nothing canceled out. So there are none. But again, if there was a part that had canceled out from numerator to denominator, for example, if there would have been another x minus 2 in the top to cancel out with one of the ones from the bottom, then they would have had a hole. But we didn't have that, so no hole. All right, next, y-intercept. The y-intercept is simply the place that happens when x equals 0. And there isn't always one of these. So we just have to make x equal 0 and solve. So let's do that. We just change the x to a 0. Now my denominator, 0 minus 2, would be negative 2. Negative 2 squared would be 4. So there's my y-intercept at 5/4. It's just above 1 right here, so it's going to cross right in that zone. All right, let's move on to the next part. Domain and range, something we haven't really talked about. So let's review, because this is something you're supposed to have had. Domain is essentially a list of all possible x values. What can x be from a left to right direction? So there's a couple of simple rules that we're going to follow, and it's on that little notes page. So most of the time our domain is all real numbers, with a couple of exceptions. All right, and the exceptions would be any place where there's a vertical asymptote or a hole. So in ours, we're going to say that it's all real numbers. That's a terrible all real number symbol. I don't know if you're familiar with it. It's like a double stick on a capital R. It stands for all real numbers, but there's an exception. X is not allowed to be, again, we're looking for vertical asymptotes or holes, so I go back up to my list, and I'm looking at these two columns. X can't be 2, because when X is 2, we get a vertical asymptote. So the domain is all reals with that exception. That vertical asymptote is the exception. All right, and then last, oops, I guess I should have put that answer up here in the box, but it's pretty small. So it would have been all reals, x not equal to 2. All right, and my last thing is my range, and range is a list of all possible y values. And once again, usually we would say that that's the set with all reals, except there's sometimes exceptions. And exceptions would be any time that there is a horizontal asymptote. There's a horizontal asymptote, which we never drew in earlier. We did have one. How did I forget that? Silly me. So I should have drew in a horizontal asymptote right here at the x-axis, which is why we didn't have any x-intercepts, if you remember from earlier. So that means it's going to be all those except x. Oh, so, whoa, y. Not x, silly. Y. Not allowed to be equal to 0, because that's where a horizontal asymptote is. So again, my range would be all reals, y not equal to 0. And if you didn't have enough space and you wrote these out somewhere else like I just did, that'd be fine. But I think there's enough space on your page. You can always zoom in a little bit and write a smaller too. All right, then last but not least, the only extra thing, and you don't have to do this, but if you wanted to finish out the picture, and we're not going to, they're too messy. If you wanted to, get your graphing calculator out and go ahead and type in this function and then kind of fill in some of the spaces. Fill in some of the things that we don't have any information for. So I'm doing that right now. I'm going to type that function out. I'm going to graph it. And I should be able to kind of see, oh, it looks like this thing comes over here on the left and then aims up and aims this way. And then on the right-hand side, it does the same thing, kind of a mirror image. So I'm not going to work. You could start plotting points and plugging numbers in and trying to find all that dots yourself, but that takes so much time. We just don't have time for that this year. So again, just use your graphing calculator. You can use Desmos. You can use any calculator that does pictures, and you can go ahead and graph that on there yourself. But that's like a bonus step. I don't care if you don't do that last part, especially if you don't have access to the calculator. All right, this is what your work looks like. Again, I'll be on the Zoom the last 15 minutes of class or so today, so if you're not sure what you're doing and you're at home, get on the Zoom. I will be there doing some problems with the kids in the classroom and anyone who's on the Zoom if you need some help. All right, good luck today.